Good morning, everyone. Now let's discuss something about probabilities. First of all, what do we mean by probability? Probability is a chance that something will happen. How likely is that something event or some event will happen? For example, if I have this coin, what are my possibilities? If I here flipped a coin, what are the possibilities here that we have? We have either head or tail, right? So the probability of getting head, for example, if I just flip a coin, it's going to be half. Why half? Because here, this is the number of heads that you have in one coin. I have only one head. And how many choices do I have generally, or how many faces do I have generally? It's two. So it's going to be half. Also here for T or tail, I have half. One tail out of how many in all? Out of two in general. So sometimes you can measure the probability with a number like 10% chance of rain, or you can use words such as impossible, unlikely, possible, even, or even chance, likely, and certain. Impossible, for example, if I have uh, this standard cube, what is the probability of getting, let's say, 9? Do I have 9 within my cube? No, I have only from 1 to 6. So it's impossible to get to get 7, for example, to get 9, for example. So the probability of getting 9 is impossible, which is 0, basically, right? Even a chance here, even chance, that means they are likely to happen, right? They are likely to happen. So this is even chance. Likely here to happen means what? Means we have it more than 50. Even chance, that means it's 50%. And likely to happen, that means it's more than 50. Something like what? Like here, those balls. If I ask you what is the probability of getting a blue ball, it's going to be 4 out of how many in all? 5, which is basically 80%, which is basically here what? 80%. Certain, so that means it's 100%, that means it's 100% sure that this will happen. If I have this spinner, for example, this is spinner, okay? If I spin this spinner here, what is the probability of getting 3? I have only one 3. Out of how many in all? Out of 4. So the probability of getting 3 is 1 out of 4. The probability of getting 4 is 1 out of 4. The probability of getting even number is 2 out of 4, which is half. So generally here, we can just write here the probability of getting an event. Let's say it's any event like even number. So any event, probability of an event equals number of favorable outcomes. That means this is actually the thing that you want to get, favorable outcomes. Okay, over here, number of all possible outcomes, of all possible here outcomes, right? Number of all possible outcomes. So this is the main rule, honestly. Here he said you roll a standard number cube once. So this is your experiment. So what are the chances here, or what are the choices that you will have? You will have 1, 2, 3, 4, 5, 6, right? Those are the numbers that you are gonna get. So here 1, 2, 3, 4, 5, 6. Those are the possibilities that you have. Okay, let's here represent the event roll an even number. So how many even numbers? So this is event E. So E here, we are going just to call it. This is the first step to find or to solve a probability question. Event E here means what? Even number. Roll an even number. Okay, and T here represent roll 3 or roll a 3 or 5. Roll a 3 or 5. So here I have two events. Here he said what is the probability that you roll an even number or? So after you determine your events, you have to see here what is the connector word, or it's like cup. Okay, so or here as a mathematician we are going to change it to be addition. Okay, here we are going to write the probability of getting roll an even number plus the probability. So here roll an even number, okay, or, which is very important word, okay, this is here the thing that is going to tell you which operation you have to use, or roll a 3 or 5. Okay, so equals what here? We said we are going to just change this one to be addition. So it's going to be probability of roll an even number, okay, plus probability of roll a 3 or 5, right? How many even numbers do I have? How many even numbers do I have? Come back to, this is 1, 4, this is 2, 6, this is 3. So how many even numbers do I have within those choices? I have here 3. Okay, so here I have 3. Out of how many in all? Out of 6. Right? Out of 6. Plus, how many 3 and 5 do I have? Only two numbers, right? So those are 2. Out of how many in all? 6. And it's going to be 5 out of 6, which is basically, if you want to use your calculator, it's going to be 5 out of 6, or you can just keep it as a fraction. It's fine. Okay, he said you roll a standard number cube once. What is the probability that you roll an even number? And so see, now here we want both. So and here, that means here we are gonna ask ourselves, do we have something in common? That means, for example, here, if I have 1, 2, 3, 4, 5, 6, those are my possibilities. The probability of getting even number 2, 4, 6, right? And second event, and on the same time, 3 or 5. Do we have something in common between them? No. This kind of event, we call it mutually exclusive. Mutually exclusive. What do we mean by mutually exclusive? What do we mean by mutually exclusive? That means exclusive. That means no overlapping area, nothing in common. Okay. So here, this end, it's going to be 0. Why? Because it's impossible to happen. It's impossible to have an even number, and in the same time, it's supposed to be one of those, 3 or 5. Because 3 is odd, 5 is odd. None of them is an even number. So here we are going to write the probability of mutually exclusive events, I mean no overlapping area, equals what? The probability of roll an even number, and which is very important, this is very important word, and here getting or 3 or 5, it's gonna be what? Impossible, which is 0. Right, continue. Here he said you roll a standard cube number. What is the probability that you don't roll an even number? Don't roll an even number, so this is probability here of do not here roll an even number. So it's going to be simply here, this one is easy to determine because if it's not even, so it's going to be in the other side, which is here odd number. Okay, but here don't roll an even number, so it's going to be as we actually use the negative side, so it's going to be here 1 minus probability of roll an even number. Okay, roll an even number, which is here going to be 1 minus 3 over 6, which is here, if you want to make same denominator, 6 minus over 6 minus 3 over 6, which is basically 3 over 6, or even 1 over 2. Okay, so even here 1 over 2. I hope it's clear at this moment. Let's move on and have this question. Okay, he said a box contains 100 balls, so those are all my possible outcomes. 30 of the balls are purple, so 30 are purple. Okay. Generally here we have 10 balls, 100, sorry, ball. Okay, or 100 balls, sorry. Right. And 10 are orange. 10 here are orange. If you select a ball at random, what is the probability of each of the following events? Events here, sorry. The probability is purple, or again, what is the connector word? Which is very important word, is what? Or. What is the connector word? It's what? Or. So I'm gonna write it here. A, the probability of getting purple or orange. Okay, so again, this is very important. How can we translate it? We are going to translate it as a mathematician, as an addition. So here the probability of, sorry, this one is not that clear. Okay, so the probability of getting purple or, so plus probability of orange. Okay, so probability of purple equals what? Probability, how many purple we have here? 30. So 3 or 0 over 100 plus probability of getting orange, excellent, 10 over 100, which is basically going to be 40 over 100, right? Which is basically 40%, right? Which is basically here 40%, right? Okay, like B here it says what is the probability that's not purple nor orange, not purple nor orange. So how can I solve this one? So not purple, so here probability of not purple, not purple, and in the same time, and not orange. Okay, not orange. Okay, so it's gonna be simply 1 minus probability of getting purple one minus probability of purple plus or minus again, so plus here, plus probability of orange. Okay, after this we are going to say not purple nor orange, so that means the left here of 30 plus 40, which is here 60, 30 plus 10 equals 40, so that means the remainder here will be 60. 60 out of how many in all? Out of 100, so it's going to be 60%. So here it's going to be what? 60%. Okay, 60%. I hope it's clear for you now. Let's move on. Okay, now we can just continue here. Probabilities of mutually exclusive events. As you can see, they are disjointed. So probability of A or, which is very important word, or B equals probability of A plus probability of B. But probability of A and B equals 0. Why? Because nothing in common. The complement of an event is a set of all outcomes in a sample space that are not included in that event. For example, if I ask you not A, for example, not an even number, so the rest of the events, the rest of the elements here that we have. So it's going to be 1, which is 100 minus probability of A, minus probability of A. Okay, see here, a student made a target includes 2 overlapping squares, assuming that a sticky ball thrown at a target equally likely to land everywhere on the target. What is the probability that the ball lands inside one or both of the squares? Inside one or both of the squares. The all possible outcomes, actually here, this is an experiment, okay? And what do I have here? I have to throw a ball or a sticky ball, and here I have my target is equally likely to land anywhere, right? So that means my all possible outcomes will be the area here that we have, right? The whole area of the rectangle. So all possible outcomes, which is my denominator, all possible outcomes here is the area of what? Area of the rectangle. Area of the rectangle. So what is the area of the rectangle here? Length times width, right? So it's going to be here length times width. What's the length here? It says 6. So 60 times 20 equals finally 0, 0, and here I have 12. Okay, 12 centimeter cube. Okay, this is all possible outcomes, but actually I want to get my ball inside one or both of the squares here, in those two squares, one of them, or even in that overlapping area. So this is my favorable outcomes, right? This is only my favorable outcomes, but pay attention that there is a repetition here. The area of a square is L times L square, so 10 square, right? And here also 10 times 10 square, but there is something here we repeat. So I'm gonna cancel it once. So here, the probability or my favorable outcomes here, my favorable outcomes here, my favorable outcomes here will be what? The area of the squares, or inside one of the squares, or both. Okay, so it's going to be the area of the yellow one, which is 10 squared plus 10 squared, but minus what? The overlapping area, which is 5 squared. It's going to be here what? 175. Right? It's going to be here what? 175. Okay. Basically, the question asks you to find probability. So I will write here probability of getting this ball here lands inside one or both of the squares, or, which is very important one, or both of the squares. Okay, so see here, what do I have? Both here of the squares, so it's gonna be inside one. So I have for the yellow one, it's gonna be 100 over 1,200. Why? Because this is my favorable outcomes, plus my favorable outcomes for the blue one is 100 again, out of what, how many in all? 1,200. There is an overlapping area as we've done up, which is here 5 squared. I mean 25 over 1,200. If you just finalize, the answer is going to be 175 over 1,200 centimeter cube, which is the final answer here will be, using your calculator, will be 15%, or you can just write it like this, 0.15, or you can just write it as 15%. Okay, hopefully it's clear for you. Let's move on and solve this one. He said a video game screen is a rectangle with dimensions 34 and 20 centimeter. So here he said the game screen is like, the shape of this is like as a rectangle, right? He said the dimensions are 34 and 20 centimeter. Okay, 34 centimeters. Okay, a star shape on the screen is made of two circles. Where is mine? Okay, so here this is the star shape overlapping. So he said there is here an overlapping area. So this is the first circle, and this is the second one. He said there is an overlapping area, which is this part. The area for this part is 20 centimeter cube. Okay, he said also that the radius is 6. He said also the radius here is 6. So I'm gonna write here the radius is 6. right? So my favorable outcome here, he said, what is the probability? So probability, it means number of favorable outcomes over number of all possible outcomes, right? So what is the probability that it appears within the star shape? So that means my favorable outcome to be here inside those two circles, or even both of them, I mean the overlapping area. So we will write here probability of this ball or starship appears within the starship. Within here, the starship. What is the starship? The starship here consists of those two circles, and we are going to subtract the overlapping area. So it's going to be what? Probability of circle 1, okay, plus probability of circle 2 minus the overlapping area, the repeated part, okay, overlapping area. So the probability here of circle, it's going to be the area of circle, which is pi r squared. So pi times r, which is here 6 squared, over how many in all times the probability of, all possible outcomes, which is the area of this rectangle. What is the area of the rectangle? It's 200 times, it's 20, right? Sorry, I wrote it. So it's 20. It's a 20 times, 20 times 34. Plus, for the other circle, by 6 squared over 20 times 34. Minus the overlapping area, which is what? 20, because he gave it to us as a general or as a number. So 20 over 20 times 34. Okay, times here 34. So the final answer here will be what? The final answer here will be what? If you just add this to your calculator, you are going to replace by with 314. So the final answer will be 0.30 or even here 30%. Okay, I hope it's clear. Let's move on. Okay, now let's differentiate between two things. If I have independent events, the outcomes of or the outcome of one event doesn't affect the outcome of the other. If A and B are independent events, then the probability of both occurring is probability of A and B equals probability of A times probability of B. Dependent events, the outcome of one event affect the outcomes of the other. So if A and B are dependent events, then the probability of both occurring is probability of A and B equals probability of A times probability of B after A. Right? What do we mean by independent events? Do you remember the spinner bar? We had there, if you still remember, we had 4 options, right? 1, 2, 3, 4. So if I want to spin this spinner 2 times, do you think that the second one here we will have, the second event here, we will have the same chance for each single bar to occur or no? Yes, it is, because the first event didn't affect on the second event. But for dependent events, for example, let's say that I have those cards 1, 2, 3, and 4. So if I ask you what is the probability of getting 3, so it's going to be what? 1 out of how many in all? 4. But what is the probability if I add here also another 4? So what is the probability of getting here 4? It's going to be what? 2 out of how many in all? 5. Okay, so this is like the difference between dependent event and independent event. Okay, see here, what are you gonna have? If A and B are not mutually exclusive, then A or B equals probability of A plus probability of B minus probability of A and B. So I have to cancel the repetition. What is an independent event? Independent events are events where the outcomes of one event doesn't affect the outcome of another. Example, like here examples: tossing a coin and rolling a number cube are independent events. Are independent events. Okay, so see here this question. It says a jar contains 12 green marbles. Now he said a jar contains 12 green marbles and 8 violet marbles. A marble is chosen at random from a jar and replaced. Another marble is chosen at random from the jar. Does the color of the first marble affect the possible outcomes of the second marble chosen? Yes or no? He said and replaced, which is very important word. When he said and replace, so that means this one. When he said and replace, that means this is and here replace, so that means this is independent event. Okay, this one is independent event. Okay, so here what shall I do? Those here are independent. So for example here, if I ask you what is the probability of getting for the first time, let's say here this is the first time. In the first time here, when you choose like a marble chosen at random, for the first time here, the probability of getting green equals what? I have 12. Out of how many in all? Because here, how many marbles do I have in all? 12 plus 8 equals 20, right? So it's going to be 12 out of 20, right? And probability of getting a violet equals what? Equals 8 out of 20. So this is for the first time. For the second time, okay, because we are going to replace it, okay? So we are going to say here, replaced. So second time here, probability of getting green again, it's going to be what? 12 out of 20, right? And probability of getting violet, because we return everything back, so this one will be 8 out of 20. Okay, so here this one we will call it independent events. So here does it affect? No. Why? Because those are independent events. So here, because here I have independent events. Independent events. Okay. Events. Okay, let's move on. And here I have a marble is chosen at random from the jar and not replaced. Not replaced here, it means what? It means here I have dependent events. The first event affect the second one. Depends on what? Based on what? Whatever we've got here. Okay? So here that I have not replaced, so I'm gonna write here not replaced. So that means directly this one is dependent. Okay, this one is dependent. Here he asks you, I am marble chosen at random from the jars for the second time. Does the color of the first marble chosen affect the possible outcomes of the second marble? Yes, it affects. Yes. For the first time, let's say here for the first time, this is for the first time. First time, the probability of getting green equals what? Equals 12 out of 20. And the probability of getting violet here equals 8 out of 20, right? For I will not return it back. I will not return it back. I will not return my marble again back. So here I'm going to just say here, suppose that the first marble was what? Marble here was green, for example. So that means we deducted 1 from the green. So now the new probability will be what? Probability of getting green, I will take 1 out of green here. It's going to be 11. Out of how many in all? Not 20 anymore. It's 19. And the probability of getting violet, it's 8, but not out of 20 anymore. So it's going to be 19. This is for the first case here. Second case here, suppose here that the marble here was a violet. Okay, suppose it was a violet one. Okay, violet one. Okay, so that means we deducted one from the violet. So the probability of getting green is what? We still have 12 green marbles, but out of what? Out of 19. And probability of violet now is gonna be what? Is gonna be 7 because we took one out of how many in all? 19. I hope it's clear for you now. Let's move on and have the question that we can solve directly. He said there are 18 cards in a box. Let's say here that five black and five red. Two cards are selected from the box. A card is chosen at random and replaced. Another card is chosen. Thus, he said and replaced. So here for A, he said and, this is A. He said and replaced. Right? He said and replaced. So what does that mean? That means here I have independent event. Okay, here I have independent event. What's the meaning of independent event? That means the first event didn't affect the second one, or the second event didn't affect it by the first event. So another card here is chosen. Does the color of the first chosen affect the card, the possibilities of the second card chosen? We are going to say no. Why? Because we replaced everything back, and since here we are going to say no. Why? Since the first card is replaced before the second card has chosen. So we are going to just write here since the first card, we are going to just write it or record whatever we've got. So the first card here is replaced after replaced here before the second card is drawn. Before the second year card is drawn. Is here drawn. Okay, for the second case here B, it says what? A card is chosen at random and not replaced. Not replaced. So as long as he said not replaced, that means will affect on the number of outcomes that we have. Not replaced means it's dependent. Okay, it's dependent. Another card is chosen. Does the color of the first card chosen affect the second possibilities of the second card? Yes, it is. Why? Because since the first card is removed and not replaced. Why? Yes, because here we are going to change the color. Since the first card is removed, so here since the first card is removed and not replaced, right? So that means here fewer cards are in the box than before replace. So then here fewer cards in the box now than before. Okay, than here before. Okay, let's move on and to solve the last thing that we have. Example 4. Alex cannot decide which shirt to wear today, so she chooses one at random. The probability of rain, which is another event, today is 40 or 2 out of 5. What is the probability that Alex chooses a yellow shirt? And so see here, it's very important to know here the word. And here it and does not rain today. So what are we going to do? We are going to write probability of Alex here chooses a yellow shirt. Okay, yellow shirt. And which is here very important word, and the probability of rain, it does not rain today. Right? So here it's gonna be and can we say here, can we judge whether it's dependent or if dependent? This one is independent. Why? Because actually, if I wear any jacket, it doesn't affect if the weather here or if it's gonna rain or not, right? So here I have independent events. So here and it's gonna be what? Multiplication. So this one will be probability of getting yellow times a probability of what? Doesn't rain today. Okay, it doesn't rain today. Probability of getting yellow here. How many yellow shirts do I have? How many yellow shirts here do we have? We have 2, excellent. Out of how many in all? 2 out of 4, excellent. Times. He said, doesn't rain today. If it's rain today, it's going to be 2 out of 5, right? But the probability of doesn't rain today is going to be 1 minus 40% or 1 minus 2 over 5, which is basically what? 1 minus 2 over 5, which is basically 3 over 5. Multiply 2 times 3 is going to be 6, and 4 times 5 is going to be 20. Finalize the answer using your calculator, it's going to be 30%. It's going to be here 30%. Okay. He said, what is the probability that Alex chooses a yellow shirt and it doesn't rain today? Or that Alex chooses a green shirt and it rains today. So here said, he just wanted to make it like a little bit complicated, but it's very easy. He said the probability that Alex chooses a yellow shirt. So a yellow shirt. Okay. And in the same time here, and it doesn't rain. Rain. Okay. This is and. Or, right? So see here, it's very important. Or what? Or that Alex chooses a green. So here Alex chooses a green shirt, and it rains. Okay. So we said word or, we are going to just change it to be what? Addition. So here I'm going to just change it to be addition. So this one is probability of yellow shirt and doesn't rain. Right? Doesn't rain. Plus probability of green shirt and it rains. And here it rains. Okay, and here we said what? This is dependent, as we said before, because if you wear anything, it doesn't affect the rain, right? Or it doesn't affect the rain. So that means this is dependent. So the dependent rule says what? The dependent rule says that and will be multiplication. So it's going to be probability of yellow times probability of doesn't rain, as we said, plus probability of green, the same thing, times here probability of rain, it rains. Okay, now just substitution, last step. So yellow, how many shirts, if you still remember the graph? It was 2 out of what, 4? Doesn't rain, we said 3 out of 5. Plus green, we had only 1 out of 4 times it rains. So it rains here, it's gonna be what? It rains here, it's gonna be 2 out of 5. So here I have 2 times 3, which is 6, 4 times 5, which is 20, plus 1 out of 4, or 1 times 2, which is 2 over 20. So it's going to be here 2 plus 6, which is 8 over 20. After this, you can just find it using your calculator, which is basically, which is basically here what? If you just find it using your calculator, it's going to be finally 40%. Okay. Okay, last thing here, which is your turn. You spin a spinner 2 times. Assume that the probability of blue each spin is 1 over 3 and the probability of orange each spin is 2 over 3. What is the probability of getting the same color of or both times? Okay, so as you can see, this is dependent or independent. We said it's dependent. Sorry, independent. Okay, so this one, it's independent events, right? Because the first event didn't affect the second one. So he said the probability of getting the same color in each. So how can I find it here? Same color. So we are going to spin it twice. So probability of getting green, here we have yellow and yellow. Orange and orange. So orange and orange. So and here, as long as it's independent, so it's going to be probability of orange times probability of orange. So it's going to be, what's the probability of orange? It says 2 over 3 times 2 over 3, which is what? 2 times 2, which is 4. 3 times 3, which is 9. Right? So this is the first one. Probability of getting, this is first one. Probability of getting match here with blue, right? So blue and blue. So it's going to be here probability of blue times probability of blue equals what? Blue here is what? 1 over 3 times 1 over 3 equals here 1 over 9. So probability of match, because he said match. So probability here of matches is going to be what? Probability of orange and orange plus probability of blue and blue, which is finally 4 over 9 plus 1 over 9, which is basically 5 over 9. Okay, I hope it's clear for you. Thank you very much. Have a nice day. Bye-bye.